Installing Omnicomm fuel level sensors. Every installation begins with preparing the vehicle and the fuel tank. After preparing the vehicle for installation and observing all safety precautions, proceed to drain the fuel tank. In case of difficult access to fuel tank top, it is required to disassemble the tank. Use a container prepared in advance by the customer or installation team to drain fuel from the tank. Then proceed to inspect the fuel tank and choose mounting location of the sensor. Make sure there is no standard vehicle equipment inside the fuel tank of baffles to interfere with the installation. We recommend installing the sensor in the geometric center of the rectangular shape fuel tank. This location minimizes any impact that fuel fluctuations inside the tank can have on the level measurements. The hole for installing the sensor at the chosen place should be drilled using a diameter 35 mm hole saw. Drill carefully at a slight angle. This will prevent metal chips and the cutout circle from falling inside the tank.
Remove any accumulating metal chips while drilling and finish drilling the hole. The final step of fuel tank preparations involves measuring the depth. You have to measure the depth at the point of sensor installation. When choosing the length of your sensor for a specific fuel tank, remember that fuel residue, water and dirt can accumulate at the bottom of the tank. The sensor must not come in contact with the tank bottom. Omnicomm professionals recommend a clearance of 1 to 2 cm between the end face of the sensor and the tank bottom. The process of cutting the sensor to length is fairly simple, and the choice of tools is quite broad. The simplest and most popular tool is a hand saw. It is compact and does not require a power source. After cutting the sensor to length, we recommend using a file to carefully smooth the cut and remove any remaining burrs.
An insulating cap is a vital component of the sensor. Fit it onto the sensor after cutting the sensor and filling the cut. Before fitting the cap onto the sensor, fill the cap with a high-quality gasoline and oil-resistant sealant to approximately 25% of its depth. This will keep moisture out of the sensor tube core. Use the reusable tool UNU to connect the sensor to a computer and configure it. The UNU comes complete with the full set of connecting cables that you may need when installing Omnicomm equipment.
Configure the sensor using the LLS Monitor application that can be downloaded free of charge from the www.omnicom-online.com website. You can use this application to find out the type of your device and the version of its firmware. Enable the data output mode. The no output mode is used with Omnicomm terminals and the majority of terminals of other vendors. In this mode, data output from the sensor happens only in response to queries from the terminal. In binary and text modes, data output from the sensor happens automatically at the specified interval, which can be configured using the data output interval option.
The next setting, network address, is important for every sensor. If only one sensor is connected to onboard terminal, you have to specify the address as 1. If there are several sensors, their network addresses must be both unique and sequential 1, 2, 3, 4. If the Omnicomm sensor is integrated into a system of other vendors, you may have to configure the baud rate. The default data rate setting for Omnicomm terminals is 19,200 bits per second. You may have to configure discrete of the sensor.
You can change both maximum and minimum readings if necessary. These settings are maximum value and minimum value in LLS Monitor application.
The filtration setting.
Filtration is a process of automatic elimination or smoothing of fuel level fluctuations. We recommend disabling this setting for stationary tanks only. One of the filtration setting values must be selected for vehicles. In case of heavy-duty vehicles operated on farmland, in mines or quarries, we recommend enabling the hard environment mode additionally.
Next, click button LLS adjustment and proceed to empty full setting.
Now proceed to calibrate the sensor, which involves configuring the full versus empty parameters. Here is one of the possible ways to configure the full versus empty parameters. Fill the sensor probe with the type of fuel in which the sensor will be used. Another way is to immerse the sensor into a calibration tube filled with fuel. After filling the sensor probe with fuel, wait for the fuel level to stabilize in the LLS monitor application, and then click the full button in the sensor configuration section of the application. The new setting will be saved in the sensor memory. Then drain the fuel from the sensor probe. Remember to open the air vents of the sensor before draining the fuel. Wait for the fuel level to stabilize in the LLS monitor application, and then click the empty button in the sensor configuration section of the application. The new setting will be saved in the sensor memory, at which point the configuration of the full versus empty parameters is completed. The sensor is ready to be installed. Perform a final fitting to make sure that you have chosen the right length and correctly marked the screw or rivet holes. The sensor delivery kit includes self-tapping screws and threaded rivets. You will need a special riveting tool to pinning the rivets. Use it to pin the rivets into holes drilled in the tank in advance. Installing the insulation cap filled with sealant. First, apply a coat of sealant on one side of the gasket and fit it onto the sensor with the sealant-coated side facing up. Then apply a coat of sealant on the other side of the seal. Install the sensor with the gasket into the fuel tank and fasten it using the chosen method, using self-tapping screws or rivets. Omnicomm professionals recommend using rivets for tank made from a metal having a thickness of less than 4 mm. Self-tapping screws can be used for tanks with a metal having a thickness of more than 4 mm. Now the sensor has been installed in the fuel tank and is ready for use. Calibrating. The next step involves calibrating the tank. An important thing to remember is that Omnicomm sensors measure the fuel level and not volume. You have to calibrate the tank to link sensor readings to a specific volume of fuel in the tank. We recommend performing at least 20 flow measurements. If the tank has a complex shape, more flow measurements may be needed. The fuel level is converted to fuel volume according to calibration tables by means of analytical software such as Omnicomm Online. Calibration can significantly improve the quality of level-to-volume conversions. The more flow measurements you make, the more accurate your conversions will be. Before calibrating the tank, you should calibrate the flow station. Do so by draining a certain quantity of fuel through the flow station into a measuring vessel. Compare the volume shown by the flow station to the volume notch on the measuring vessel, and make adjustments to the flow station according to the manual if necessary. During the tank calibration process, fill the tank with fuel in portions and record the tank volume values and the corresponding sensor level readings in the calibration table. It is very important to record the readings only after the fuel level has stabilized in the LLS monitor application. After recording new values, press the Enter key. This will add a new table row with the new fuel volume increased by a pitch that corresponds to the previous pitch. If you enable the synchronization function, the F4 key enables the synchronization mode, and the F5 key disables it. The sensor level readings will be synchronized with the table automatically. With the tank is full but the sensor level reading does not correspond to the maximum level notch. This is normal. In this case, you should manually add one more row to the table and increase the fuel volume in the row by 1 liter compared to the previous row. In the sensor reading column, specify the maximum reading shown by the sensor, which is 1495 in this case. Once the calibration has been completed, it only remains to feed the seal. At this point, installation of the sensor is completed. Let us briefly sum up all the installation steps. Step 1. Inspecting and preparing the vehicle and the tank for sensor installation. Step 2. Draining fuel from the tank and drilling a hole for the sensor. Step 3. Preparing the sensor for installation, cutting the sensor to length with a clearance of 1–2 cm from the tank bottom. Step 4. Installing the insulation cap filled with sealant. Step 5. Configuring the empty versus full parameters. Step 6. Installing the sensor in the tank. Step 7. Calibrating. A total of 7 steps. An experienced professional needs about 2 hours to install the sensor, from preparing the vehicle to sealing the fuel tank. Our video tutorial is over. Thank you for your interest in our product. We wish you many successful and interesting projects.